Hello everyone, welcome to CH for us. Today we'll be solving problems related to mole concept. Assuming the density of water to be 1 gram per centimeter cube, calculate the volume occupied by one molecule of water. So here they have given that the density of water H2O is equal to 1 gram per centimeter cube. Now we have to calculate the volume occupied by one molecule of water H2O is equal to how much? We all know the formula that density is equal to mass by volume. In terms of mole, how do we write this? Density is equal to molar mass by molar volume. So they have given that density is 1 gram per centimeter cube. And what is the molar mass of water? 1 mole of H2O is equal to 18 grams. This is the gram molecular mass. It is also called as molar mass, which is equal to 6.022 into 10 to the power 23 molecules of water. So now here we will substitute molar mass as 18 grams by molar volume. So what will be the molar volume? Volume is equal to 18 grams by 1 gram per centimeter cube. Grams and grams gets cancelled. We will get 18 centimeter cube as our volume. Okay. Now 1 mole of H2O is equal to 18 centimeter cube. The volume of 1 mole of H2O is 18 centimeter cube. Then what will be the volume occupied by one molecule of water? So 1 mole of H2O is equal to 18 centimeter cube, which is equal to 6.022 into 10 to the power 23 molecules of water H2O. We have seen here, right? Okay. Then what is the volume occupied by one molecule of water? This is the question. One molecule of water occupies how many centimeter cubes? Okay. 1 into 18 centimeter cube by 6.022 into 10 to the power 23, which is equal to, when you solve this, you will get the final answer as 2.989 into 10 to the power minus 23 centimeter cube. Okay, so volume occupied by one molecule of water is 2.989 into 10 to the power minus 23 centimeter cube. Now next question, calculate the number of moles. In this question, you have to completely focus on this number of moles. First, in the first case, you have to calculate the number of moles in 392 grams of sulfuric acid. Sulfuric acid formula is H2SO4. H2SO4. Okay. 1 mole of H2SO4 is equal to, what is its gram molecular mass? 2 hydrogens. 2 sulfur's atomic mass is 32. Oxygen is 60. 4 oxygen atoms. 16 into 4, 64. So 98. Okay. 98 grams. Then the number of moles in 392 grams is equal to how much? 392 by 98. You'll be getting 4 moles. Okay, 4 moles of H2SO4 is present. Okay, now the second one. You have to calculate the number of moles in 44.8 liters of carbon dioxide at STP. What is STP? STP is standard temperature pressure. Standard temperature and pressure. Temperature here is 0 degrees centigrade. Pressure is 1 atmospheric pressure. 0 degrees centigrade in Kelvin it is 273 Kelvin. Now they have asked us to calculate number of moles in 44.8 liters of carbon dioxide at STP. 1 mole of carbon dioxide at STP. STP is taken only for gases. At STP is equal to 22.4 liters. Then 44.8 liters of CO2 contains how many moles of carbon dioxide? 44.8 into 1 by 22.4, you will be getting 2 moles of CO2 is present in 44.8 liters of carbon dioxide at STP. Now we'll see the third question. Calculate the number of moles in 6.022 into 10 to the power 23 molecules of O2. O2 is oxygen molecule. 1 mole of O2 is equal to 32 grams. This is gram molecular mass, which is equal to 6.022 into 10 to the power 23 molecules of O2. So they have asked here the number of moles in 6.022 into 10 to the power 23 molecules of O2, which is 1 mole. So the answer is 1 mole. Now we'll see the fourth one. Calculate number of moles in 9 grams of aluminium. Aluminium is equal to how much? 1 mole of aluminium atom, okay, is equal to, aluminium is 27 grams. Its gram molecular mass is 27 grams. Now, 9 grams of aluminium contains how many moles? 9 into 1 by 27, which is equal to 1 by 3, which is equal to 0.33 moles of aluminium is present in 9 grams. Okay. Now we'll see the next question. So we'll see our next question. Calculate the number of moles in 1 metric ton of iron. Again, here also you have to calculate number of moles is equal to how much? First, in 1 metric ton of iron, 1 metric ton is equal to 10 to the power 3 kilograms. So 1 mole of iron is equal to, iron is 56 grams. Its gram molecular mass is 56 grams, which is equal to 6.022 into 10 to the power 23 atoms of iron. Okay, now they have given us that we have to calculate the number of moles in 10 per 3 kilograms of iron. So 10 per 3 kilograms can be written as 10 per 6 grams is equal to how many moles? 10 to the power 6 into 1 by 56. So your answer will be 1.786 into 10 to the power 4 moles are present in 1 metric ton of iron. Now the second one here is calculate the number of moles in 7.9 milligrams of calcium. 1 gram is equal to 1000 milligrams, which is equal to 10 to the power 3 milligrams. We know that 1 mole of calcium atom is equal to 40 grams. This is the gram molecular mass, which is equal to 6.022 into 10 to the power 23 atoms of calcium. They have given that the number of moles should be calculated in 7.9 milligrams. You have to write this 7.9 milligrams in grams. So 1 gram is equal to 1000 milligrams. Then 7.9 milligrams is equal to how many grams? 7.9 by 1000, which is equal to 0.0079 grams. Okay. So then 0.0079 grams contains how many moles? 0.0079 into 1 by 40. You will be getting the answer as 1.975 into 10 to the power minus 4 moles. You have to calculate. Okay. And write it. I will only give the final answer. You have to calculate it. Now we'll see the third one. You have to calculate the number of moles in 65 micrograms. I have already said in the previous video that 1 millimole is equal to 10 to the power 3 moles. 1 micromole is equal to 10 to the power 6 moles. 1 nanomole is equal to 10 to the power 9 moles. Okay. So I have already said that 1 millimole is equal to 10 to the power minus 3 moles, 1 micromole is 10 to the power minus 6 moles, 1 nanomole is 10 to the power minus 9 moles. You have to keep these conversions in mind. So here they have given that 65 micrograms of carbon is equal to how many number of moles. So you have to convert this micrograms into grams. 65 into 10 to the power minus 6 grams of carbon. This is given. Okay. Now, one mole of carbon is equal to 12 grams, which is equal to 6.022 into 10 to the power 23 atoms of carbon. Then 65 into 10 to the power minus 6 grams contains how many number of moles? 65 into 10 to the power minus 6 into 1 by 12 grams. You have to get the answer as 5.458 into 10 to the power minus 6 moles. Okay, when you cancel this, you will be getting 5.458 into 10 to the power minus 6 moles. So this is how we calculate number of moles. Now we will be calculating the mass. Mass is equal to how much? First, in the first case, 0.1 mole of KNO3 is equal to its mass is equal to how much? So 1 mole of KNO3 is equal to potassium is 39, nitrogen is 14, its atomic mass is 14, 3 oxygen atoms into 16 is 48. So you will be getting 101 grams. This is the gram molecular mass of KNO3, which is equal to 6.022 into 10 to the power 23 molecules of KNO3. They have given 0.1 mole of KNO3 weighs how much? This is 1 mole. Then 0.1 mole of KNO3, 0.1 mole of KNO3 is equal to how much? 0.1 into 101 by 1, which is equal to 10.1 grams. Okay, so 0.1 mole of KNO3's mass is 10.1 grams. Now we'll see the second one. You have to calculate the mass of 1 into 10 to the power 23 molecules of methane. Methane is CH4 is equal to how much? 1 mole of methane is equal to carbon is 12. Its atomic mass is 12 plus 4 hydrogens, 16 grams, which is equal to 6.022 into 10 to the power 23 molecules of methane. Now, 1 into 10 to the power 23 molecules of methane weighs how much? 1 into 10 to the power 23 into 16 by 6.022 into 10 to the power 23. Your answer will be some 2.657 grams. So, mass of 10 to the power 23 molecules of methane is equal to 2.657 grams. We will see the third question. You have to calculate the mass of 112 centimeter cube of hydrogen H2 at STP they have given. So, here hydrogen is a gas H2 at STP is equal to how much? So first you have to write 1 mole of H2 at STP is equal to 2 grams, right? Which is equal to 22.4 liters. Its volume at STP is 22.4 liters. So this 22.4 liters can also be written as 22,400 centimeter cube. Why? Because 1 liter is equal to 1000 milliliters, which is equal to 1000 centimeter cube, which is equal to 1 decimeter cube. You have to keep this conversion in mind. So, 1 mole of hydrogen H2 at STP is equal to 22,400 centimeter cube. Then 112 centimeter cube of hydrogen at STP weighs how much? 112 into 2 grams. You have to consider these two, volume and gram molecular mass. 112 into 2 divided by 22,400. So you will be getting 0.01 grams. Okay, this is the mass of 112 centimeter cube of hydrogen at STP. Here, arrange the following in order of their increasing masses in grams. So you have to calculate the masses first and then you have to arrange it in the increasing order. First, 1 atom of silver. What is its mass? 1 mole of silver Ag atom is equal to 108 grams, which is equal to 6.022 into 10 to the power 23 atoms of silver. These many atoms mass is 108 grams. They are asking the mass of 1 atom of silver. Then 1 atom of silver is how much? 1 into 108 by 6.022 into 10 to the power 23 is equal to 1.793, something around that you will be getting, into 10 to the power minus 22 grams. Okay, you have to calculate and then you have to write this final answer, which is 1.793. 1.79 something 3 or whatever it is into 10 to the power minus 22 grams. Now, 1 gram atom of nitrogen weighs how much? 1 gram atom. They are not saying 1 atom or they are not saying 1 gram of nitrogen. They are using here the term 1 gram atom. I have already said that 1 mole of any atom, here they have given nitrogen, will take nitrogen. Nitrogen atom is equal to 14 grams. Okay, what is this 14? It is gram atomic mass. As we have taken nitrogen atom, this is gram atomic mass. It is also called as 14 gram atoms. Okay, generally it is 1 mole of any atom is equal to its gram atomic weight, or 1 gram atom, which is equal to Avogadro's number of atoms. Okay, this is the general form. Here we have taken nitrogen. So it has 14 gram atoms, which is equal to 6.022 into 10 to the power 23 atoms of nitrogen. This gram atom is what they are asking here. So for 1 gram atom of nitrogen, it is equal to, how much does it weigh? So 1 gram atom weighs how much? 14 gram atoms weigh 14 grams, right? So 1 gram is equal to, not 14 gram atoms. Okay, 1 second. $14 grams or 1 gram atom. This is 1 gram atom itself. It's not 14. So for 14 gram atoms, weight or the mass is how much? 1 gram atom is 14 grams. Then 14 grams gives us for 1 gram atom, they have already given that 1 mole of nitrogen atom is equal to 1 gram atom, which is equal to 14 grams. Therefore, 14 grams is equal to 1 gram atom of nitrogen. Okay, you should not get confused here. Okay, now this is the answer for the second one. Now the third one. They have asked to find the mass of 1 mole of calcium. 1 mole of calcium is equal to 40 grams. This is direct. Okay, this one is equal to 1 gram atom. Okay, not 40 gram atoms. It's 1 gram atom. This is the answer for third one. Then fourth one. Find the mass of 1 mole of oxygen molecule. 1 mole of oxygen molecule O2 is equal to 32 grams. Okay, this is for the fourth one. Next, fifth one, you have to find the mass of 10 to the power 23 atoms of carbon. 1 mole of carbon is equal to 12 grams, which is equal to 6.022 into 10 to the power 23 atoms of carbon. Then for 10 to the power 23 atoms of carbon, what is its mass? 10 to the power 23 into 12 by 6.022 into 10 to the power 23. 10 to the power 23 and 10 to the power 23 gets cancelled. You will be getting something around 1.99. Yeah, this is the answer. Okay, 1.99 grams. Now, the sixth one, 1 gram of iron. That's it. They are just given 1 gram of iron. They did not tell 1 gram atom of iron's mass is equal to how much. They did not ask. They have asked what is the mass of 1 gram of iron. Directly it is given 1 gram is equal to the mass here in the sixth one. So we have to arrange it in the increasing order. So first, the 1 atom of silver weighs least. Okay, 1 atom of silver. Its mass is very less. Then second comes which one? 1 mole of carbon. 1 mole. Is it 1 mole of carbon? Where is it? Yeah. Fifth one. 10 to the power 23 atoms of carbon. You have to write what is given in the question. 10 to the power 23 atoms of carbon. Then comes, after 1.99 we can write which one? The 14 grams, right? Okay, in between this you have to write this one also, 1 gram of iron. Okay, 1 gram of iron and then 10 to the power 23 atoms of carbon. Then after that we'll be taking which one? 14 grams. 14, 32 and then 40. 14 is for 1 gram atom of nitrogen. 1 gram atom of nitrogen. Then we'll be taking 32 for 1 mole of oxygen molecules. 1 mole of oxygen molecules. And then we'll be writing 1 mole of calcium, which means calcium's mass is highest in this given order. Okay, here you have to see I have added 1 gram iron. Okay, so that's it. In the next video we'll be solving few other problems of mole concept. Thank you.